Definitely, I'm going to show how to use a Casio's fx-570EX Classwiz calculator to solve heat equation using implicit finite-difference method. Okay. Consider we have one-dimensional uniformly heated rod with an initial temperature Ux0 equal to Hx, which is considered as this is as an initial condition. We have the Uxt is actually temperature distributions. The temperature distribution of the heated rod, which is placed on the x-axis from 0 to L, 0 to L, where the heated rod can be described by the heat equation del U del T equal to C squared del 2U del X2, and the C squared is the thermal coefficient. X is the position of the rod, T is the time T, and the rods here is positions at X here. Let's say this is a rod put at X equal to 0 up to X equal to L. So we have the given T0, so this is what we call initial condition, T0. The temperature of the rod is, let's say, given by function Hx, and we have two border at two sides of the rod. So this will be considered as left boundary condition, where x equal to 0, the temperature of the rod, let's say, is given by function ft, and at the right end, so ULT is a right boundary condition, let's say given by the function Gt. And we have seen how to solve the heat equation using explicit finite-difference method. Now we are going to see how to solve it using Crank-Nicolson's implicit method. So by using implicit method, the heat equation del T Q, we initially solve it using numerical. It is actually we have del T Q at the point xi, let's say Tj, is equal to C squared del 2U xi Tj del T2. Now for the Crank-Nicolson implicit method, the heat equation is approximated at the point xi Tj plus r. So if explicit is solved at the point xi Tj, but in this case, implicit is solved at the point xi Tj plus half. So this is where the time t is represented in vertical axis, x is represented in the horizontal axis, and x is discretized using the I variable, t is discretized using the j variable. So we approximate the heat equation using implicit method at the point xi. X is at position I, t is at the position j plus r. So let's k is a delta t. So here we have the k over 2, in this is actually delta t over 2. So from j plus half, add up with a k over 2, you get level j plus 1. If you keep minus k over 2, you get level j. So here from j to j plus 1, the center will be j plus half. So at the x-axis, center is I, right is I plus 1, left is I minus 1. So the heat equation is approximated at the point xi Tj, where the U bracket xi Tj plus half can be simplified as a notation U subscript I comma j plus half. So now we are going to use this is first derivative, del U, del T is first derivative, right hand side is del 2U del x2, which is second derivative. For first derivative is approximated now compared to explicit method. Now this is using 3-point centra. Explicit is using 2 point forward. Now it's 3-point center, centra approximated at the point uij plus r. So differentiate respect to P using 3-point centra. We are standing at the cross here. We take the point ahead, okay, in the forward point minus the backward point. That's why we have uij plus 1 minus uij. So K total we have K over 2 plus K over 2. So total is Q. That's why K for right hand side, left hand side. Okay. Delta T uij plus half using 3-point centra. Okay, for time. We get uij plus 1 minus uij divided by K. And for the second derivative, del 2u del x2 is average, okay? It's actually taking average, okay? It's actually, yeah, okay, standing at the cross here. Then for second derivative, we have at the level j plus 1. So for del 2u del x2 is actually average, okay, of the approximation at the point uij plus 1 with xij plus 1 and xij with xitj. So that's why c squared okay, over 2 is actually we average it, because we average these two, that's why c squared over 2. Okay, del 2u at the point xitj plus half, okay, and then differentiate respect to x, okay, del x2. So another one is at the point xitj. So how to get this term and this term is actually using the second derivative, okay, numerical differentiation for second derivative. Have here f xi minus 1 minus 2 f xi plus f xi plus 1, okay, divided by h squared. Okay, where the h is actually the delta x. So we want to find, okay, del 2u del x2 at, okay, this point. So you notice here, okay, this is left one time, current point minus 2, okay, forward point 1 time. So we have here this point ui minus 1 j plus 1, okay, in this one. When we average it, so you have c squared over 2, okay, del 2 del x2 ui j plus 1. Okay, so for uij plus 1 and then plus del 2 del x2 uij. Okay, for uij plus 1, okay, uij plus 1 will be c squared over 2. Okay, uij plus 1, okay, focus on level j plus 1. We have ui minus 1 j plus 1. Okay, I hope you understand the notation. Okay, this point will be, okay, uij plus half. So this is it. Top, this is level j. So left is I minus 1, center is I, right is I plus 1. That's why this will be ui minus 1 j plus 1. This is uij plus 1. Okay, this point is ui plus 1 j plus 1. Okay, go down. Okay, this at the point x is at the I plus 1. This is level j. So this is uij, this is ui minus 1 j. So okay, for level j plus 1, we will have ui minus 1 j plus 1 minus 2 times here. So minus 2 ui j plus 1, and then this point, okay, 1 time. So plus ui plus 1 j plus 1. Okay, this is for level j plus 1. Okay, so you need to add up, okay. For level j, you just replace your j plus 1 here, okay, by j. So you have ui minus 1 j here. Compare here, this j plus 1 is j. Okay, x is same, I minus 1. So minus, okay, center point here 2 times. So minus 2 uij. So plus ui plus 1 j. So that's what we get here. This line. Okay. So after that, okay, similarly, okay, we bring the k, okay, to the right hand side, using cross multiplication. So you have here 2. The left side become 2 times bracket uij plus 1 minus 2 uij, and then right side got kc squared over h squared, which is denoted as a r. So you have r times ui minus 1j plus 1. Okay, this is minus 2r, this is plus r, this is r minus 2r plus r. Okay, and then so we'll bring all the j plus 1 to left side. Okay, the level j bring to right side. That's why this become minus r. Okay, so this become plus 2r here. This is minus r. And then initially got 2 uij plus 1. Collect, we take this term when you bring to left side become positive 2r. That's why I get 2 plus 2r uij plus 1. This minus r. This becomes positive because bring to left side positive and positive 2 collect together. So this minus r. This maintained at the right hand side. So positive r. Okay. Positive r here. This one. This is minus 2r. This is plus r. Okay. This one minus 2 uij bring to right side. So become positive 2 uij. So that's why I get equation 9.6 here. So from the equation 9.6, if we draw to the draw the molecule graph, so we have a two-level scheme. Bottom level is level j, okay. Top level is j plus 1. Okay, and at each level you have 3 molecules, left, center, right. Okay, for top K level, left K molecule, the coefficient is minus r, center is 2 plus 2r, right is minus r. Okay, at the bottom level, okay, the left cell is positive r, center is 2 minus 2r, right cell is positive r. So this one become implicit because top level you have more than one cell. You compare to the previous K video, okay, if explicit, normally your top targeted level will be only one cell. So your top cell directly depends on the bottom level. So but this one you have more than one cell at the K targeted top level. So it becomes implicit scheme because when you apply this molecule to the grids, you will get system of linear equation to be solved simultaneously. So it becomes implicit method. So when you apply the molecule to the grids, you will get it. So you notice your top level you got what? Minus r, 2 plus 2r minus r. When you apply to the grids, you get 3 diagonal matrix. 3 diagonal matrix at the this is a left side vector, a left side matrix equal to right hand side. The bottom level of the molecule, remember you have r, 2 minus 2r, r. This one because at the boundary. At the boundary. This one also at the boundary, which is collect at this vector. Initially plus r, so collect at here. So this 2 is boundary. This one also, these 2 points because of the boundary. And look at one example. The initial temperature of the metal rod of length 1 meter is given by ux0 equal to x squared for x from 0 to 1. Okay, and so we draw the grids first. So x from 0 to 1, x from 0 to 1, okay, delta x is 0.2, okay, delta x is 0.2, so from 0, 0.2, 0.4, 0.6, 0.8, 1. Okay, and given the initial condition is x squared, so I can use the table menu to quickly tabulate the initial condition 9. So the function is x squared. Okay, starting from 0, ending from 1, increment is 0.2. So I get here. So the initial condition is tabulated quickly. 36.64 compared to, you may use calculate menu also. Okay, you may use calculate menu, input the function x squared and you calculate 6 times. Okay, and this table, this model is actually you have okay, you can have okay, two functions okay, of one function. We got two functions. Okay. Let's say the second function I did have is 0. Second function is 0. Okay, and you can also get the graph okay, from the table menu okay, by okay, pressing the QR, which is yellow color, so you need to press the shift. Okay, then you may use your handphone to scan and get the graph. This is for the fx, which is x squared. And then move number 1 back. Cos key, you also can use key in the function and then you calculate. So you calculate 1 by 1 x 0. Look at 0. And then they may equal or press calculate 0.2. Okay. So you get this one 0.04. Calculate again. So x now is 0.4. 0.16. Calculate again. X is now 0.6. 0.36. Calculate again. X now 0.8. 0.64. Calculate again. X now 1. So if you use calculate normally, we don't have the uniform increment and calculate 1 by 1. If you know the starting, ending, and the uniform increment, you can use table menu to directly calculate it to be faster. So we have draw the grids, x, okay, and t, t is actually time t from 0 up to 0.04, and delta t equal to k up to which is 0.02. So t 0, 0.02, 0.04. So we have filled in the initial condition. Now we need to fill in the boundary condition. Okay, the right boundary u1t. So the right boundary all are equal to 1. Okay, left boundary is actually t exponent negative 2. Okay, so we may calculate. So of course we don't have the t variable in calculator. Okay, you can only use a red color as a variable. So A, B, C, D, E, F, X, Y, M. So in this case, I change the t to x. So alpha x, and then exponent alpha x. Oops. Exponent is equal to. We also may use the table menu also. You calculate left boundary. Calculate. Okay, in the actual variable is t, but in calculator we don't have t. I input as x. So initially x 0. So you get 0. Calculate. So x in calculator is 0.02. You get 0.0196. Calculate. Okay. 0.04. You get 0.0384. Or we use table is number 9. Okay. Input is alpha x. Exponent negative alpha x. X will then have 0. Starting is 0. Ending is 1. Okay. And so ending from go up 0.04. Step side 0.02. And get it faster than you use a calculate menu. Okay, we have filled in the draw the grids, fill in the initial condition, boundary condition. So now we need to find x is discretized using the variable I, which is start from 0, 1, 2, 3, 4, 5. This is variable I. Okay. T is discretized using j, start from 0, 1, 2. So this cell is x is 1, I is 1, j is 1. So u1 1. So here j same level, j same. So I increase. So u2 1, u3 1, u4 1. Go down. Go up. Sorry. J increase, but x maintain. u4 2, u3 2, u2 2, u1 2. So we got 8 cells to solve. And each level you got 4 cells. So you get four simultaneous equations to be solved. Okay, to be solved. Then you solve level 1, done. Then you solve level 2. Okay, level by level, each level, because you got 4 cells. Okay, 1, 2, 3, 4. So you have 4 simultaneous linear equations. Okay, how to get the simultaneous linear equation? So we get back the molecule of the implicit method of heat equation. Remember this molecule. Okay, how we get the molecule? If you cannot memorize, then you derive again. Okay, derive again. Okay, delta delta using 3-point centra at the point xi, tj. If you cannot memorize, okay, then you have to derive again here. And then for del 2u, del x2 is average, okay, at the point, okay, xi, tj plus 1, and at the point xi, tj, so c squared over 2. Then this is using 3-point centra, 3-point centra, simplify, you get here, change the molecule. The top level is negative r, center top 2 plus 2r, right top minus r, bottom is positive r, this is 2 minus 2r, this is positive r. So we now calculate the r value, where the r is kc squared over h squared. Okay, then the r, we have kc squared over h squared, which is same with our explicit method for heat equation. So k 0.02, kc squared is a coefficient from your heat equation, 0.75, and then divide by h squared, so 0.2 squared. So we get the node number 1. So we have k is what? K 0.02. Kc squared is 0.75 divided by h squared, h is 0.2 squared. So 0.375. So r, you get 0.375. Here. So this cell is minus r. This is 2 plus 2r. Okay, where you got 2 plus 2 times answer, which is 2.75. So this is minus r. This positive r, positive r. Okay, this is 2 minus 2r. 2 minus 2r. 2 minus 2 times r, which is 0.375. Okay, so you get 1.25. Okay, now we are going to apply this molecule to the grids. In this molecule, okay, where the molecule we have negative 0.375 here. This is u I minus 1 j plus 1. Okay, and this we have 2 plus 2r, which is 2.75 u I j plus 1 in the top level. Okay, this one is negative 0.375. This is u I plus 1 j plus 1 equal to, okay, this is 2 minus 2r, where you get 1.25 u I j. Left positive 0.375 u I plus 1 j. Okay, left here 0.375 u I minus 1 j. U I minus 1 j. This molecule we apply here. Okay, and as we mentioned just now, you get system of linear equation where your left hand side matrix, you get ax equal to b, where the a is given by the top, the molecule at the top level. Main diagonal is 2 plus 2r, off diagonal is minus r minus r. Okay, so you for your this one first. You should get here. So we have a u equal to b. A main diagonal 2.75. Okay, off diagonal 3 diagonal matrix only. Off diagonal is a minus r. So you want to solve for level 1 form U11, U21, U31, U41. So this is your metric U equal to B. How you can get your B quickly? How you can get your B quickly? Okay, if manual, you apply your molecule. Okay, if you're using manual way, when you apply, you get with negative 0.375. You apply the molecule here, this molecule. So negative 0.375. Okay, first time we apply here, you get first equation. So it's negative 0.375 times this cell, which is U01, so U01, plus 2.75, okay, multiply U11 minus 0.375 times U21 equal to, okay, this is the right hand side. Okay, right hand side, okay, how I get the matrix? Because this one, when you calculate, this is a initial condition. If this is boundary condition, you get this is actually as a vector B. Vector B. Okay, how you get the vector B here? How I get this vector B? The same thing. Apply the bottom level of your implicit molecule, two-level molecule. This is once you apply like here, this cell is positive 0.375 multiply this value actually 0. This is U01, this is U10, U20, U00, 10, 20. Coefficient 0.375, 1.25, 0.375. When you apply first time, you get first equation. Okay, later on, you move here. Okay, consider here. The yellow color that I highlight second time. So, okay, the molecule coefficient the same, only the cell, the cell here. Now you move from X at the J, I at number 1. So you see U11, U21, U31. Okay, bottom level U10, U20, U30. Okay, if third time, if you erase this one, third time, this yellow, okay, third time. So you start with, this is U21, U31, U41, okay, bottom. Okay, so U20, U30, U40, because coefficient of X is same, only the level 1, okay, at the right side is a level 0. Okay, and the fourth time, because of the 4 cell, okay, so the fourth time, okay, you apply here, first time and second time, third time, fourth time. So start with U31, U41, U51, okay, at the right side, U30, U40, U50. Okay, and then you plug in the boundary condition. Here U0, okay, U01, okay, and here U51 here 1. Okay, plug in the this is a boundary condition. Okay, this is another boundary, left boundary, right boundary. Okay, these are all the value from the bottom level here. So you notice here, so you may write 1, 2, and then you need to key in to the calculator. Okay, in manual, okay, you write this one, then fill in boundary value, okay, and the initial value. Okay, at the bottom level, here, U00, the value 0, 0.04.16. Okay, later on, the second time, this is your 0.04, 0.16, 0.36. Okay, and then move. Okay, 0.16, 0.36, 0.64. Okay, and then 0.636, 641. Then you need to press all these 4 lines. It is troublesome. So what we are going to do, we are going to input into the calculator. Okay, the top molecule, the top level molecule will lead to 3 diagonalmetric. Off diagonal, main diagonal is 2 plus 2r. Off diagonal is minus r. Then how to get the vector B quickly? So vector B here is actually, you notice 0.375, and then this value I represent as ABC. Okay, where the ABC, when you first time, When you target to solve the U11, you target to solve U11, the A, B, C is the left bottom, center bottom, right bottom. So when you target at here, U21, then second time, U21 the center. So when you target here second time, this is A, B, C. So you input to the calculator. Okay, now the formula is actually from the bottom level molecule. You can put the formula 0.375. Left bottom represent using A, and then the center bottom coefficient is 2 minus 2R, which is 1.25. The center bottom cell represent using B. The right bottom coefficient is 0.375. The value represent using C. Then you calculate. Now first time we apply molecule like here is actually the target to solve for U11. So A left bottom value is 0. B is 0.04. C is 0.16. But this one not yet because first equation you have the right boundary. Minus 0.375. U01 is 0. Is 0. Oh, that's why this one times 0, you get 0. That's why first level you get the answer 0.11. This one not 0. So you make a mistake. U0 level 1. Level 1. This one multiplied 0.0196. This one is I calculate here, and then I need to add up with negative 0.375 times U01. I is 0, J is 1, so this value 0.0196. Bring to right hand side, so become plus 0.375 times 0.0196. So which is 0.1247. This one 0.11 plus this one, this value bring to right side plus 0.375 times 0.0196. 0.1174 because this one I can fix to 4 decimal place. It manual you calculate 0.375 times 0 plus 1.25 times 0.04 plus 0.375 times 0.16. Select this term. But here what I'm using is because the right hand side you have the same pattern, only your A, B, C value change, which is the left bottom, center bottom, right bottom value change. So I get the first value here, 0.1174, and now to calculate the second equation, we need the B value for the second equation. For second equation, we need to do second equation. To highlight the yellow color here. So we calculate again. Now A is here. From 0, the A move to here. This will be A, B, C. So A is 0.04. B is 0.16. C is 0.36. Here exactly you don't have boundary condition, so we equal. So this will be the B value for the second equation, 0.35. Because you see this is manual calculation. You don't have that's why second row full molecule. This one you see where is a negative 0.375. It's collect to the vector B in the first row. So you get 0.35. And then calculate again. For third equation. Third equation Okay, you move, start from here. So A is from 0.04 move to 0.16. Okay, B here 0.36. C 0.64. So quickly you get the answer 0.75. 0.75. This one. Okay. Let me see again. This one. This is the A, C. This is a B, the third equation, right? This is a C. Okay, calculate again. Okay, the last equation over here. So A is 0.36. Okay, from 0.16 move to 0.36. B 0.64. C 1. Okay, however, the last equation, top level is you have a boundary which is 1. Boundary which is 1. Be careful. Top level, okay. Negative 0.375 times 1, which is a constant value. You see the last equation, these two, this one, negative 0.375 times with the right boundary. So you need to collect back with the B value at the fourth row. So you need to plus, because negative bring to right side become positive 0.375. The right value is 1. So times 1. So you get 1.681. Okay, so now you have system of linear equation to solve for your first level. So you know this case, first time the gray color, you get U11 in center. Second time U21, third time U31, fourth time U41. Okay, and you may quickly solve this linear equation, system of linear equation using your calculator. Equation works. Okay, this model you can solve up to 4 simultaneous equations. Compared to the old model, you can solve up to 3. Then just key in the coefficient, row by row. Okay, and then negative 0.375, 0, 0, 0.11735. Second equation, negative 0.375, and then 2.75, negative 0.375, 0, 0.35, third equation 0, negative 0.375, okay, and then 2.75, okay, negative 0.375, okay, the B3.75, okay, the fourth row 0, 0, and then negative 0.375, okay, and then 2.75, and then 1.685. Okay, check before you solve it. The vector B is 5.35, up 0.1174, 0, 0, 0, negative 3.75, 2.75. Check it, the value 2.75 negative 3. The second variable, negative. Okay, correct it. So you get this is a U11. Y exactly your U21. I want X96, 3894, U31, the Z, the T is a U41, 6658. Okay, this is level 1. Okay, once the level 1 is done, okay, you fill in the value here, you will move up the molecule. Okay, Then repeat the process like just now. Repeat the process like just now. Okay. Back to the one. Formula no longer there. Repeat back the process just now. How to get vector B quickly. Key in our formula at 0.375 alpha A plus this R, then 1.25 alpha B. You key in the molecule at the bottom level, okay, where the ABC represent left bottom, center bottom, and right bottom. So plus 0.375 alpha C. Okay, you get the the matrix A is always main diagonal 2 plus 2R, off diagonal is a negative R. So you are going to solve for level 2. So this is U12, U22, U32, U42. Here, let's show how to get the vector B quickly. So you calculate it now. So A is here. This is A, this is B, this is C. So A 0.0196, B 0.0685, C 0.1897. Okay, but this is not the value yet because top level top level, and apply here, you have here this one negative 0.375 time. This one is actually your boundary value, which is 0.0384. U02, which is 0.0384. Okay, at the first and the last equation, you have to be careful. First equation, you need to add up this term. Negative 0.375 U02. U02, the value is 0.0384. And then apply the molecule. Okay, this is negative 0.375 times this value. So you need to add up back plus 0.375 times this value, 0.0384. So you get 0.1785 here. Okay, and for the intermediate, no problem. Only the first and the last equation, be careful of the boundary condition. Subtract formula, calculate. Okay, second equation, just now, highlight using the yellow color. That we have used is ABC. Okay, for second equation, solve on the top second level. This is level 2, the level 1, the level 0. Second equation. This one, we're going to solve actually. This is U, this is 012, U22. So calculate the A is here. This is B, this is C. A 0.0685. B 0.1897. C 0.3894. So you get 0.4088. Okay, and then for third equation, third equation is third equation. We need to solve. This is first time, second time, third time. So this is 4, 8, 0, 1, 2, 3, U32. We need to solve for U32. Okay. First time solve U12. So this center top here. Second time, this is a second equation, center top here U22. Third time, the center top is U32. And then your ABC value, this is A, this is B, this is C. So calculate again. A now 0.1897. Okay, B 0.3894. C 0.6658. So you get 0.8076. Okay. And the last equation, you target the center top at your U42. Last equation, center top at your U42. Okay. Then your molecule, okay, the yellow color here. So this is a ABC is here. A, B, C. Again, A now is 0.3894. B 0.6658. C 1. However, be careful here. The last equation, you have why you miss the negative 0.375 times 1. Manual, when you calculate manual, and go here. Negative 0.375 times 1, which is value where you need to collect the right side to become plus 0.375. Okay, times 1. Right boundary is 1. So you get 1.7283. And then you can get to solve your U 1, 2, 2, 2, 3, 2, 4, 2, even here. Quickly again using the equations menu. And the same thing, we go to equation menu, key in these 4 simultaneous equations just now, then we get this one. So I'm going to conclude back for heat equation. Heat equation. Del U del T equal to C squared del 2U del X2. It's solved by Crank-Nicholson implicit method. Okay, the heat equation is solved actually at the point xi plus half, plus half. Okay, and the del U del T is solved using 3-point centra. So you have Uij plus 1 minus Uij. Okay, del 2U del X2 is actually, we solve at the point Uij plus 1, then Uij, and then average it. So you just C squared average at the point Uij plus 1 and at the point Uij. And each Uij plus 1, at the second derivative, using the numerical derivative for second derivative. So left point 1, center point minus 2 is point 1. So this is level J plus 1, level J, level J, the red color. Okay, simplify. Delta K, this is a delta T is K, cos by K, 3-point centra, here. So KO2 plus KO2 means Uij plus 1 minus Uij. So you got 2 times of KO2 or KO2 plus KO2. This is, here you get delta T. You use cross multiplication. So 2 times here. Kc squared OH squared, which is represented as R. Simplify it. You get a molecule, which is a 2-level molecule. It's 6K molecule here, 2-level. So if the top level more than one cell, you get implicit because you get system of linear equation. Okay, if explicit, your top level will be only one cell. So top level cell is directly depend on the bottom level. You can get the value directly, but in this case, you get system of linear equation. So you get your system A U equal to B. Okay, where the matrix A is or where main diagonal is a R, off diagonal is given by your main diagonal is 2 plus 2R, 2 plus 2R, 2 plus 2R. Okay, off diagonal is minus R. minus R minus R. 3 diagonal. You get the 3 diagonal matrix AU equal to B. You always get the 3 diagonal matrix where the main diagonal is a 2 plus 2R, is a center top molecule. Off diagonal, we have actually left top, right top. The coefficient is negative 0.375. And the right boundary, the vector B is actually vector B dependent on your molecule, bottom molecule, where the coefficient is R times, this is a left bottom cell plus 2 minus 2R center bottom cell plus R times right bottom cell. Where I use a calculator to represent this left bottom as A, center bottom as B, C as a right bottom cell. To get the vector B quickly. I get vector B quickly using the formula. Using the formula. In this case, my R is 0.375, so I key in 0.375 on A. The center bottom coefficient is 2 minus 2R, 1.25. So this I represent using B, plus 0.375 C. Then you can get the vector B quickly, but be careful. The first equation, you have to add up that. Take care of the top boundary condition, which is negative 0.375, this one, times your boundary Casio. This one when applied, this is actually negative 0.375 and this value. So this value you have to collect to your right hand side. And then at the last equation, we have also this cell negative 0.375 by 1. So you have to collect it, collect to your right hand side vector. And then you can, once you get the system of linear equation, you can, if up to 4 simultaneous linear equations, you still can use your scientific calculator. Only this model, Classwiz model, can solve up to 4 simultaneous equations. If the ESFS, you can solve up to 3 simultaneous linear equations. Once the level 1 is done, you move up the molecule to target at the top level. First time, when you target, this is U1, 2. U1, 2. When you target at U1, 2, you get here, first equation. So when target U1, 2, this is a A, this is a B, this is a C. So when you target here, U2, 2, A, B, C, move. If target U3, 2, A is here, B is here, C is here. When target U4, 2, A, B, C. A, B, C. So but be careful, the first and the last equation have to take care of the boundary condition here. This boundary condition. So but the intermediate row, no problem. You can just use a formula 0.375 under A. This is a A value, this is a B, this is a C. Then you can use the equation for know to get the answer quickly. So with this, thank you for your attention.